welcome to today's crash course on the states of matter. The topics we're going to cover in today's crash course are primarily meant for Secondary 1 and Secondary 2 students. But if you're a little bit older, Cycle 2, you might want to stick around to refresh your memory. So today we're going to be covering three topics: the three states of matter, or also called the three phases of matter, the 6 changes in state, as well as phase change diagrams, which can be a little bit tricky sometimes to read. So before we talk about the states of matter, let's define what matter is. Matter is any substance that makes up something with a mass. So all matter is made up of particles, or atoms. So some examples of matter are wood, skin, my shirt, blood, oil, air, and those things exist in 3 states. We call them the 3 states of matter. So we have solids, liquids, and gases. And we're going to get into more detail about those in just a minute. But first, a question. Solids have a definite shape and volume. True or false? The answer is true. So here we have a pair of ice cubes, which is an example of water in solid form. And this is actually one of our states of matter. And the thing to remember about solids are they have a definite shape and a definite volume, which means that these ice cubes stay in the same shape no matter where you put them, in an ice glass or on a piece of paper. They will always remain solid and they will always take up the same amount of space. So other examples of solid substances are wood, steel, paper, and cold butter. Just some examples for you. Particles of matter in solid state are usually very organized. So here we have an example of solid water. And as you can see, the particles are packed very closely together. They're held together by very strong bonds, and they vibrate in place. We can say the same for the chair you're probably sitting on. It's a solid, but those particles that make up that chair are vibrating very, 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 very small. So the movement is small, but it exists. And the only time where particles stop moving on the planet Earth is at absolute zero, which is at minus 273.15 degrees Celsius. So drinking water and juice and milk are examples of liquids, liquid states, if you will. And so the cool thing about the state that's a liquid is that it has a definite volume and an undefined shape. So here we have this bottle of water, and this bottle of water we're going to say is a liter. So we have a liter of water, and if I take that liter of water and I put it in a bucket, that liter of water still is a liter, but it changed shape. It's taken the shape of its container, and that's the cool thing about liquids. Other examples of liquid substances you could see are oil, blood, milk, and rain, and even soy sauce. But remember, properties of liquids, they always have a definite volume, but they could take the shape of their container. So particles in liquid state, like in our example here of liquid water, you can see that they are further apart. They're further apart from each other, and that's because they are held together with weaker bonds. And so the thing about particles in our example of liquids is that they vibrate in place, but they also slide past each other, and they also can rotate. So there's a little bit more fluidity to their movement, which is why we get that kind of flowy vibe. The last state of matter is the gaseous state, and air and water vapor are examples of that state. So a couple of things to remember. Properties of gases. They have an undefined volume and an undefined shape. So what does that mean? Well, it means gases take the shape of their container. Other examples of gaseous substances are air, helium, laughing gas, and carbon dioxide. So particles of matter in gaseous state are very disorganized, as you can see from our gaseous water diagram here of particles. So particles and gases are very far apart from each other. They are held together by very weak bonds, and there's not really any method behind their movement. They are very disorganized and erratic. And so when we walk through a room, we know there's oxygen in the room. We know there are different types of gases in the room, but we're not getting hit in the face with particles because there is such weak bonds between particles and there's space between the particles. So we might feel a little breeze on our face, know that there's gas in the room, but it's not like if we were swimming through water. So that's kind of the difference between the states of matter and their separation of particles. So here you can see that we have the 3 states of matter side by side, and you can see the difference in the organization of the particles. So in a solid water, sample, you can see that the particles are a lot more organized and a lot closer together. And then if you move over towards the gaseous water, so our water vapor, you can see that there are a lot less particles and there's not really any organization and they're a lot further apart. So just remember, it's very important. The nature of the substance of particles doesn't change from one state to the other. So water is always going to stay water, even in solid state, liquid, or gas. But the distance between the particles changes from one state to the other, as you can see from these diagrams. So let's move on to our 6 phase changes. The first one, we're going to take an example, and I have my candle here. And our candle is in a solid state, but when we add heat, the candle wax will melt. This is called fusion. And as you can see here with the red arrow, we're going from a solid state to a liquid state, and we are adding heat. We're heating it up. We're using, other words, melting. And just a reminder, melting point is the specific temperature at which a given substance becomes a liquid. And so the melting point can be very specific. It depends on the substance. So for example, water melts at 0 degrees Celsius, and the melting point of iron is at 1,535 degrees Celsius. So if we go in the opposite sense and we go from a liquid to a solid state, we have an example here where icicles are formed when liquid water drips off of a roof and freezes. And so this process is called solidification. And as you can see with the blue arrow, we are lowering the temperature. So it's a cooling. So water is cooling and becoming a solid state. Let's try a question. Solidification always occurs at very low temperatures. True or false? The answer is false. Solidification doesn't always happen at low temperatures. For example, a fresh pizza right out of the oven. The cheese is gooey and it's stretchy and it's very malleable and delicious. And then if you leave it out on the table for a long period of time and you let it cool down, it becomes more solid, almost like a crust. So solidification doesn't happen here. In this case, it happens at room temperature. It doesn't always happen at freezing temperatures. If we have a substance in liquid state and we want to turn it into a gaseous state, we have what's called evaporation or boiling. And evaporation is a little bit of a slower process. So here we have wet clothes suspended on a line in the sun. And as temperatures increase, those water molecules that are in the wet clothing evaporate. And also we can use our example of boiling where we add extreme heat. Okay, so the temperature is increased dramatically, and so those water molecules will then turn into water vapor. And this change in state is called vaporization. And usually we also say boiling point. So boiling point is the specific temperature at which a given liquid substance becomes gaseous. And remember that boiling point is specific to the substance. So a boiling point of water is 100 degrees Celsius, and that's different than the boiling point of iron, which is 2,750 degrees Celsius. And in the opposite process, if we take water vapor that's in the air and it touches a cold can of soda, we can see that those water molecules, because there's a decrease in temperature, will then turn into a liquid. And this is called condensation. And as you can see, we go from a gaseous state to a liquid state, shown by that beautiful blue arrow, which shows that there is a decrease in temperature. We have 2 phase changes left. So here we have a solid air freshener that will release gas particles into a room to make it smell nice. And this process is called sublimation. And as you can see with the red arrow, we are moving from a solid state to a gaseous state because there's an increase in temperature. So when you use this example, it's better in a hot room than in a cooler room. Our last phase change goes from the gaseous state to a solid state. And so here we have a freezer. And so in the air, we have water vapor. And when that water vapor touches the cold sides of a freezer, it deposits and it solidifies. And this is what's called deposition. And you can see by the blue arrow that we are decreasing in temperature, going from a gaseous state to a solid state. So there you have the 6 changes of state. And you have to just remember that every single state, solid, liquid, and gas, can change based on whether you increase or decrease the temperature. Another important thing to remember is that a change of state is a physical change because the particles that make up the substance remain the same. So water throughout this demonstration still was water. It was just in solid, liquid, and gaseous form. So now we're moving on to phase change diagrams. They can be used to show the heating and the cooling of any substance. So let's have a look at our first diagram, which is the diagram for the phase changes of water. So as you can see over here, we have our temperatures, which is on the vertical, and then we have our time on the horizontal. And this is showing that water is actually rising in temperature. Okay, so we see already the fact that there's going to be some changes happening here. So we do at the bottom here, we're starting at minus 40 degrees Celsius. So for our first section, we see that the water is now in solid form. Okay, so because water is frozen at this point at minus 40 degrees Celsius. So if we move up the graph and the temperature gets warmer, then we hit what's called a plateau. And this section here is called a phase change. So during the plateau, you can see that the temperature remains constant. And that means that right now, the solid is turning into a liquid. Then we continue moving up the graph. And the graph for section 3, the water is in liquid state. But then once we reach 100 degrees Celsius, which is the boiling point of water, we see another phase change. So anytime there is a plateau in our graph, we know that there is a phase change happening. And as you can see, the temperature remains constant again. So here we have vaporization happening. And then as we move up the graph to section number 5, as you can see with the red, it's water vapor. So again, we went from solid, phase change, liquid, phase change, gas. The phase change diagram can also be used for cooling or when temperatures are decreasing. So here in this diagram, we have ethanol, and ethanol is a type of alcohol. And so as you can see from this diagram, it's starting from a very high temperature and it is cooling down. So it's going downward, if you will. What does section 4 correspond to on the ethanol temperature versus cooling time graph? Is it A, liquid state, B, solidification, C, deposition, or D, solid state? The answer is B, solidification. So here, just looking at our cooling graph, we can see that ethanol is starting out in a gaseous form, and then it will condensate. And condensation will happen at approximately 78 degrees Celsius. And remember, a phase change is when we see that plateau and temperature stays constant. Then the ethanol is going to go down this third section and stay in liquid form, and then it's going to hit another plateau. And when we see a plateau, so number 4 in this case, we knew from our last question that this is solidification. Okay, so solidification is when we go from a liquid to a solid. So that phase change is happening for section 4. And then we go down and we continue into ethanol in solid state. And remember that also, I forgot to mention, that the plateau phase change happens at minus 114 degrees Celsius. So it's not at all like water where we think it's 0. So remember that solidification can happen and it's based on the specific substance. So in this case, minus 114 degrees Celsius. So there you have it. Today we talked about the 3 states of matter, solid, liquid, and gas. The 6 changes of state, solidification, fusion, vaporization, condensation, deposition, and sublimation. And then we also talked about our phase change diagrams. So keeping in mind that when we see those changes in state, they can be put in these diagrams so that we can better see how the temperature is increasing or how it is cooling. And don't forget that when you see those plateaus, they mean either melting point, solidification, or boiling point condensation. Don't forget to practice.